So you've just heard about some of the world-class research that CAASTRO astronomers do, but as well as doing the research, CAASTRO aims to inform the public about the research they're doing through outreach programs, and we have our main school outreach program is called CAASTRO in the Classroom, which is a program of free video conferencing sessions for schools and live streaming sessions. So what you can see here is one of our video conferencing screens. This was a presentation on special relativity for Year 12 students. And if you look at the top of the screen, you can see Joe Callingham, one of our PhD students who gave the presentation. So this type of session can be delivered to 20 schools at a time through video conferencing systems. But this year we've also started doing live streaming sessions. So this is one of our live streaming sessions which featured Scott giving the main presentation, and I did a demonstration using liquid nitrogen as well. So we had about close to 50 schools register for this session, and that went to about 2,400 students all over Australia. So CAASTRO in the Classroom started in 2012, and it started as a collaboration between CAASTRO and the New South Wales Department of Education. And then in 2015 we got a grant to expand the program nationally. That was through the Australian Maths and Science Partnership Program, so that's a Commonwealth Government grant program. So that's allowed us to expand nationally, also to employ some classroom teachers who've worked with us on developing classroom resources, and that's what I'll be sharing with you today. So in the photo there you can see two of the teachers that worked with us, Sylvia Choi and Neil Dorrington, and also Sandra Woodward worked with us on these resources. This is just the CAASTRO in the Classroom website. So I'm going to give you a flyer that has all the web address and everything. So on that website you'll find information about our video conferencing and live streaming sessions. There's links to our classroom resources and information about professional development workshops that we do. And this is what we're offering in 2017. So we're going to keep doing our curriculum-focused video conferencing sessions like the special relativity one. And we're going to keep doing some live streaming sessions. We're going to add to that though a more interactive Q&A type session. So that will connect an astrophysicist with one school at a time, so they might be talking to a class of 20 or 30 students. They'll tell the students a bit about themselves and their research, and then the students can ask questions that they've prepared before the session. And that can be delivered through video conferencing, but also through Skype, because not all schools have video conferencing systems. So that allows more schools to participate. These are just some screenshots of the presentations we've done this year. So what we've been doing this year is recording all of our video conferences and live streaming sessions and then making them available through YouTube. So if schools can't participate live, they can use the video itself as a resource. I'm just going to show you quite a busy slide which has all the topics that we've done this year. I'll just go through the different topics that we've offered schools this year, and these are all available online, and we've also got classroom resources that go with these. So starting in the top left corner, we've got Awesome Astronomy for Year 5, so that was the session that Scott did. So that was for Year 5, and then for Year 7 we have Solar System and Beyond. Now all of these topics are linked to the Australian curriculum for science, and also there's the topics for Year 11 and 12 are linked to the New South Wales HSC syllabus, with a focus on the content that's common to the Australian curriculum for physics as well. Now in the Australian curriculum, Year 5 and Year 7 content, there's quite a bit of overlap with the astronomy topics, so those resources really can be used across the stages. This topic, Year 7 to 10, Why Study Physics? So that was presented by Dr. Vanessa Moss. She's a postdoctoral researcher here at CAASTRO, and she talked about her own interests and her life and studies and what led her to becoming an astrophysicist. Now this was the first live streaming session we did with a live Twitter feed. So during the presentation, schools could tweet in questions and they appeared on the screen, and then Vanessa answered some of the questions at the end. Now this recording, if you've got any students who are a bit undecided about whether to take physics in Year 11 and 12, it can give a perspective from someone who did follow that path and became an astrophysicist. Up the top there, Year 10, Big Bang, How to Make a Universe. So that was presented by Dr. Luke Barnes. He talked about the evolution of the universe and related it to his own research in cosmology, which involves running computer simulations on supercomputers. Also for Year 10, The Dark Side of the Universe, that was presented by Professor Tamara Davis from the University of Queensland. Tamara is an award-winning astrophysicist and also a really great public speaker as well, so that's a great presentation. For Year 11 we have Cosmic Engine, which is very much about the preliminary physics topic for New South Wales. And Year 12, Gravity in Orbits, a successful rocket launch, which again, it's quite specific to the New South Wales syllabus, and Special Relativity. So for each of those year levels I just mentioned, the teachers that worked with us have developed classroom resources that go along with those topics. So they're all free to download from our website. They come as a Google Doc or a Word doc, so you can look at them on any device. And I guess we did it in that way so that teachers can cut and paste and use bits and pieces, or they can use the whole package. Using the whole package, you can use it as like a pre-visit activities before participating in a live session or a recorded session, and then post-visit or follow-up activities. So for each topic we have a glossary of terms, and there's revision videos. Now this is really a list of curated YouTube videos. So the teachers spent quite a lot of time going through existing videos and finding the ones that link to the syllabus. They also spend a lot of time searching the internet for existing astronomy resources, in particular online interactives like simulations and things that give students a bit of choice and make students a bit active in their learning because they can manipulate things and change things. There's some practical activities, and we'll get a chance to do some of those soon. And for senior secondary, there's some exam style questions. This is the classroom resources part of the website, just to show you that we list the year level, the topic, the Google Doc and Word doc, and also a link to the video. Now I'm just going to show you some of the, I guess, technology related resources that the teachers have really recommended as being useful in the classroom. Have any of you used Stellarium before? So a couple of people have. Stellarium is free software that you can download to your computer. There's also a free online version which we've mentioned in the Year 10 resources. There's a link to that. So Stellarium is like having a planetarium on your computer. So you can look right across the whole of the night sky. You can set the date and time and location. You can move around and have a look at things, and you can click on individual objects, then it brings up loads of information for each object in the sky. The next one is Solar System Scope. So this is a free online program, so you run it on the internet. This is great for Year 5 and Year 7 when they're looking at the solar system. And what you can do with this one is you can look at the solar system from pretty much any angle. You can watch how the objects orbit the sun. You can speed up time to see how they move in relation to each other. So it's great for giving an overall picture of the solar system. And like in Stellarium, you can click on the planets and it comes up with information about individual objects. And here we have Starwalk. So this is an iPhone or Android app, smartphone app. And this is also a bit like having a planetarium, but on a handheld device. So you can hold it up at the sky. Have any of you used one of these apps? So there's a few free ones around. Skywalk has a paid version that just has more features. So you can hold them up and look at individual constellations. You can click on stars and reveal information about them. So it's a great tool for amateur astronomy. So I just wanted to show you three of those technology sort of resources. In each of the sets of resources that I'm showing you, and I've got copies of them for you to look at in a moment, for each of the year levels we've got 3 or 4 different online tools that can be useful in teaching astronomy topics. So as well as finding existing resources, we've developed some of our own. This one is an investigation to do with supernovae. So it's useful for Year 10 or Year 11. And this is using some real astronomical data that we've got from some of our researchers at the ANU. On the left-hand side here, you can see an image of a supernova. Now that's taken from the Hubble Space Telescope, which is very good at taking pretty images. So a supernova is a catastrophic event that occurs at the end of the life of a star. It's a very bright object in the sky, and astronomers look out for when they occur because it's something that changes in the night sky. The images we used for this investigation came from the telescope pictured there. It's called the SkyMapper telescope. It's in Coonabarabran in New South Wales. And what SkyMapper does, it's a very hard-working telescope. It's got the job of taking a survey of the whole of the southern sky over 5 years. And what it does, it takes snapshots of the same area of the sky repeatedly so that astronomers can look for any changes. So these are 2 of the images that we use in the investigation. Not as pretty as the Hubble image, but we can do a fun activity with them. Sylvia Choi, who worked with us on this, she came up with 2 different ways of getting students to analyse these images to look for supernovae. So these images are of the same patch of the sky, just taken at different times. So one of them has a supernova in it, and the other one doesn't. Can anyone spot where the supernova is? You think you can see it? Okay, so one way of making it easier to spot any changes between the images is to make a little GIF file to just flick between them. So that's the first activity. So it just makes a little video so you can see that little supernova there, or big supernova, coming and going, so you can see the change. The second version of this investigation is a little more challenging, and what it does is it gets the students to subtract one image from the other to try and find any changes to look for a supernova. So this uses free online image processing software, and this is the result that you come up with. And that's where the supernova is. So it's a bit of an approximation, but it gives students an idea of what astronomers do. Now, astronomers really don't just use free online software to subtract the images, they use fairly sophisticated software, because what they need to do is correct for changes in atmospheric conditions. So if images are taken at two different times, the air temperature is different, there could be wind, and that's going to affect how objects appear. So what they do is they look at objects that don't change in their brightness and use that as a marker to correct for any changes in the conditions. Another thing we've been doing is providing animations for teachers to use in the classroom. The ones on the left here, they're the first two in the list. They're new animations that we've commissioned. The one at the top is on muon decay as evidence for the special theory of relativity, and this one's on redshift. So they're freely available through the website and on the CAASTRO YouTube channel. And then there's more in that list. A lot of these were existing CAASTRO animations that researchers use in their presentations. And what we've done is we've gone through and found the ones that are most relevant to the curriculum. So they're all there free to use. And I'll show you one of those towards the end of the session. The final thing I want to show you is our researcher profiles. Now, one of the things that's unique about CAASTRO, I guess, is our researchers. And one of the requirements of the school curriculum is that students have some understanding of the process that scientists use and also some awareness of Australian research. So what we've done is we've created profiles of some of our researchers. And for each researcher, we've got a set of questions and answers where we find out a bit about their background, what they enjoyed as children and what they've studied and what position they have now. They talk about the sorts of skills that are important for their research, and reading a few of them, you find that there's common skills. Like they use computer programming and communication and those sorts of things that are quite important. As well as the researcher profiles, our teachers came up with some classroom activities to help students engage with the profiles. You can see an example of one of those there. It's quite a rough one, but the idea is to make a poster for the researcher and a business card. And another idea is to have a mock scientific conference. So you might get the students to take on the roles of the scientists and move around the room and interact with each other and find out if there's any commonality between their skills and the type of research they do, and give presentations. And they can even have a grants round where they have to compete for funding and argue the case for why their research should get funded instead of someone else. Okay, so that's a lot of the resources. What I'm going to do now is introduce you to some of our hands-on resources. I'll just demonstrate a few of them, and then what I'll get you to do is just move around the room and have a look at them for yourselves. So I'll just show you a few things now. Okay, first of all, we have some soft drink cans, and you'll have to try this for yourself. You can find out what a soft drink can weighs on Earth and how it would feel on Jupiter and the Moon. And there's a whole classroom activity based around that idea. This is a neat little activity where you get to find out the relative distances from the sun for all the objects in the solar system. There's instructions on the back, and to do this one you use this black strip of paper. So it involves folding the paper to work out the distances of the planets and that sort of thing from the sun. This is a simple spectroscope. So we've got a CD, there's a little slit at the end of the box. The idea is you aim that at a light source and then look straight down onto the CD and have a look at the spectrum. You can make a basic telescope. There's materials for that over there. So the idea is it slides in and out, and you can bring an object into focus with that. This is a good one for special relativity, talking about inertial and non-inertial reference frames. Have you seen one of these before? It's an accelerometer. So we've got a bottle of water in the middle, a cork floating in it. If I was to move forwards, which way do you think the cork will move? Okay, we've got two different options. Let's see. I'll try it again. So when I'm accelerating, it moves forwards. And if I move around in a circle, it moves to the centre. So it moves in the direction of acceleration. So you can have a think about why that happens. This one is a very simple way of remembering what goes on with redshift. So it's just a slinky. Can I have a volunteer to help me with this one? Do you mind just standing up? If you can just grab the end of it. And let's say I'm a light source. If I'm moving away from you, and we say each loop is a wavelength, what's happening to the wavelength? It's getting bigger. And if I move towards you, it's getting smaller. So that's just an extremely simple model of redshift. And what I have here, it's a resistance band like you get at the gym, that sort of thing. Can I have another helper? Would you mind helping me? Can you just hold the end of it? I'll just grab some pegs. So what I'm going to do is just put the pegs in a few spots along here. And this is a model of the expansion of the universe. I mean, you do it a bit more carefully in the classroom, but let's say they're equidistant apart, and if we stretch, they move further away from each other. And if you have a whole lot of pegs across here, what you can see is that the space between the pegs increases. The pegs themselves stay the same. So you can just do measurements and see that the same increase in space happens between each of the pegs. There's a bit more of an explanation on the instruction sheet as well. I've got a couple of other ones I don't have instruction sheets for. I just want you to think about how you might talk about this in relation to astronomy. So it's a bit of a challenge. If anyone comes up with a great idea, you win a Milky Way at the end. These are just glitter tubes. The way I made these is with clear glue and water and lots of glitter. So I don't have any particular thing to tell you about that, but just have a think about what you could talk about in relation to an astronomy topic. And finally, you've probably seen one of these before, or a tornado bottle. All right, so what I'd like you to do is get involved in the activities here. At the end, we'll all come back together. And if you've got any thoughts about the activities and how you might use them in the classroom, and also if you've got particular success stories you could share with us about astronomy activities you've done in your classroom, that'd be great too. Okay, thanks. Go and play.